visualization, sometimes called mental imagery or mental rehearsal, is the process of creating vivid pictures in your mind of actions, outcomes, or scenarios without physically performing them. At first glance, it might seem like daydreaming, but neuroscience shows that imagining an activity activates many of the same brain circuits as actually doing it. Have you ever mentally rehearsed a speech or visualized scoring a goal before a game? That simple act of imagining engages your brain's motor, sensory, and planning areas, strengthening the very neural pathways you'll use in real life. How can imagining something produce real changes in the brain? The answer lies in synaptic plasticity, often summarized by the phrase neurons that fire together, wire together. When you vividly picture yourself performing a task, networks in the motor cortex, premotor areas, and even the cerebellum fire as if you were physically moving. Functional MRI studies reveal striking overlaps between imagined and executed actions, meaning mental rehearsal primes your brain for performance by reinforcing the connections needed for that skill. Consider elite athletes who swear by visualization. A basketball player mentally rehearsing free throws can improve shooting accuracy nearly as much as physical practice alone. Musicians do the same, mentally running through difficult passages before ever touching their instrument. In rehabilitation, stroke patients use guided imagery to reactivate motor circuits and regain lost movement more quickly than with physical therapy alone. These examples show that visualization can accelerate learning and recovery by strengthening targeted neural pathways. Which brain regions are most involved? Visualization taps into a distributed network. The premotor and primary motor cortices plan and initiate movement. The parietal cortex integrates sensory information, the basal ganglia support habit formation, and the prefrontal cortex oversees planning and attention. The mirror neuron system, neurons that fire both when you act and when you watch someone else act, further enhances your ability to learn by imitation. But how effective is mental practice compared to physical practice? Research suggests mental rehearsal can account for about 30 to 50% of the gains achieved by actual practice. Its true power lies in complementing physical training, especially when fatigue, injury, or logistical constraints limit hands-on practice. The most efficient approach blends both. Physical repetition solidifies muscle memory, while visualization fine-tunes neurocircuitry and decision-making processes. Visualization isn't foolproof. Its effectiveness depends on vividness, concentration, and correct technique. Poor imagery can reinforce bad habits, so it's crucial to practice under realistic conditions. Include multisensory details, sights, sounds, feelings, and combine visualization with feedback, either from a coach, a mirror, or video playback. Looking ahead, emerging technologies like virtual reality and neurofeedback promise to make visualization even more potent. VR environments can provide immersive, lifelike scenarios for rehearsal, while real-time brain monitoring can guide you to adjust your mental imagery for maximum neural engagement. Ultimately, visualization transforms abstract thought into concrete neural change. By consciously directing your mind's eye, you harness the brain's plasticity to build, refine, and strengthen the circuits that underlie skill, creativity, and recovery. Could mastering visualization be the key to unlocking your brain's full potential? The growing body of evidence suggests it just might be. Visualization, mental imagery, engages the brain's sensory and motor regions without external stimuli, triggering activity patterns similar to actual perception or action. Repeated visualization strengthens synaptic connections via Hebbian plasticity. Cells that fire together wire together, reorganizing neural circuits over time. This neuroplastic change enhances the efficiency and speed of relevant neural pathways, improving performance even in the absence of physical practice. Visualization thus acts as a cognitive rehearsal that primes the brain's hardware for future tasks. Athletes mentally rehearsing a golf swing activate motor cortex circuits almost identically to performing the swing physically. Visualization is like running software diagnostics on hardware. It fine-tunes circuits without physically using them. Functional imaging studies show that imagining visual scenes or actions recruits primary sensory cortices, prefrontal planning regions, and associative networks. The overlap between imagery-induced and perception-induced activation underlies visualization's power to simulate experiences internally. This co-activation strengthens multimodal integration pathways, enhancing sensory discrimination and cognitive control. Over time, visualization can produce measurable anatomical changes, such as increased gray matter density in targeted brain regions. Musicians visualizing finger movements on an instrument exhibit increased connectivity in motor planning areas. Mental imagery is like virtual reality inside your brain, creating lifelike simulations that train your neural hardware. When neurons fire together during vivid mental imagery, their synapses are potentiated according to Hebb's rule, reinforcing the associated neural circuit. This process consolidates imagined experiences into durable memory traces and procedural templates. Because visualization can repeatedly evoke the same firing patterns without fatigue or physical strain, it accelerates skill acquisition and retention. Consistent mental practice thus carves stable pathways that mirror those formed by physical practice. Surgeons who mentally rehearse a complex procedure show faster improvement in surgical simulator performance. Visualization is like repeatedly tracing a route on a map. It engraves the path into your mental GPS. Combining mental rehearsal with physical practice yields greater performance gains than practice alone, thanks to complementary strengthening of motor and cognitive networks. Visualization refines error detection by pre-activating neural sequences, allowing subtle adjustments before real execution. Over time, this integrated approach accelerates automaticity and reduces cognitive load during task performance. Visualization thus functions as a low-risk, high-efficiency training tool for complex motor and cognitive skills. Basketball players who visualize free throws daily improve shooting accuracy faster than those who practice only on the court. Visualization is like warming up an engine before driving. Ensuring all parts are primed for optimal performance, imagining calming scenes or successful outcomes engages prefrontal cortex regions that modulate limbic emotional centers, reducing stress and anxiety. Repeated practice strengthens top-down inhibitory pathways, making it easier to shift away from negative thought patterns. This neural rewiring underlies the sustained mood improvements seen in mindfulness and guided imagery interventions. Over time, visualization cultivates resilience by embedding adaptive coping circuits. Patients visualizing serene nature scenes before surgery report lower perioperative anxiety and pain. Visualization is like installing noise-canceling filters in your brain, quieting emotional turbulence. Neurofeedback trains individuals to consciously modulate brain activity by providing real-time EEG or fMRI feedback during visualization tasks. This closed-loop approach accelerates plastic changes by reinforcing desired neural patterns on the spot. Over sessions, targeted regions become more responsive to mental imagery, enhancing self-regulated control of attention, mood, and motor output. Neurofeedback thus amplifies visualization's potency by making invisible brain states visible and adjustable. ADHD patients using neurofeedback with visualization improve sustained attention and reduce impulsivity. Neurofeedback is like having a mirror for your brain, letting you tweak neural performance in real time. Visual mental rehearsal activates hippocampal cortical networks critical for memory encoding and retrieval, strengthening long-term storage of imagined content. Sleep after visualization further consolidates these traces, integrating them into broader knowledge schemas. This mechanism explains why visual mnemonics dramatically boost retention of complex information. Over time, visualization training enhances both episodic memory capacity and recall speed. Students using the memory palace visualization technique recall lengthy lists with high accuracy. Visualization is like stamping information onto archival film, ensuring it's stored clearly for later playback. Visualization therapies aid recovery from neurological injury by activating residual motor circuits, promoting cortical reorganization and functional compensation. Imagined movements can mitigate muscle atrophy and improve motor planning when physical practice is impossible. Visualization also supports mental health by reshaping maladaptive thought networks underlying depression and PTSD. Stroke survivors practicing mental walking exercises regain gait function faster than those receiving conventional therapy alone. Visualization therapy is like rebooting a malfunctioning computer program. It restores function by retraining existing code. Advances in brain computer interfaces will integrate visualization with immersive VR and AI-driven feedback, customizing imagery content to optimize plasticity. Machine learning models can predict which visualization protocols best reshape specific neural circuits for individualized training. Combining real-time neuroimaging with adaptive visualization exercises promises accelerated rehabilitation and peak performance enhancement. This convergence of technology and neuroscience heralds a new era of targeted precision brain training. VR platforms that adapt guided imagery scenarios based on live EEG patterns are under development for elite athletic training. Future visualization tools will be like personalized brain gym trainers, continuously adjusting workouts for maximal neural gains.